So for my discussion, I chose to do the Osmosis egg experience. So what I have here are 3 raw eggs, each in a glass. The first step of this experiment is to let them each soak in a glass of vinegar for 24 hours. So today is day 1. It is about noon on Friday. So I'm going to start by just chopping them all up with vinegar. All right, so we're gonna leave them like this for 24 hours, see what happens, and then we're gonna do the next step. Upon initial observation, you can already see there's a lot of bubbles forming around the shell of the egg. All right, so here we are. It has been about 26 hours since we initially put the eggs into the vinegar. So I did 3 eggs just in case for some reason one didn't turn out, but pretty much immediately yesterday after putting the eggs in the vinegar, they started to bubble, and now they're at the point where if you kind of swish them in the vinegar, you can't hear the shell anymore hitting the side of the glass. And there's still lots of bubbles in the vinegar, so we're gonna get ready here and rinse the eggs off and put them into their next solutions. All right, so here we have the 3 eggs that I had soaking in the vinegar for the last 26 hours. You can see on this one here, just the abrasiveness from the gloves has kind of rubbed what was left remaining of the shell. It's rubbed it off, and then we have this one here on the end that's still pretty much intact for the most part looking. I mean, it definitely has a different consistency. The eggs are a bit pliable. You can squeeze them a little bit. And then on the end here, we have it compared to, that is just a regular unsoaked egg. So it still has an intact shell. And you can definitely see a significant size difference between the ones that were in vinegar as opposed to the one that hasn't been. All right, so now with our 3 eggs, my control egg, I'm just going to put back into a glass, and we're going to leave it. So that one there will be our control. One we're going to put in the glass and add water. And then another one, we are going to add corn syrup. So there. Have the eggs back in the glasses. We're gonna do corn syrup in the blue cup. That should be about enough. And then add water. And then I'm just going to position a spoon on top of both of them to make sure that they don't come up out of the water. All right, and then we're going to leave those for 24 hours. So we are here, and it's about 28 hours since the last update. I just removed the spoons from each cup, so now they have risen to the surface a little bit. But yeah, so we're going to remove the eggs from the cups and see what they look like. So here on the far left, that is the egg that we didn't do anything with. It didn't go in the vinegar, no solution, just regular egg. The second one that we have here, that one was soaked in vinegar for the 24 hours, but after that we just set it aside. This one here, that was the one that we had soaked in water. So it was in the vinegar for 24 hours and then into water for about another 27 or so hours. And then our final one here that looks a bit deflated, That's the corn syrup egg. So it was in the vinegar for 24 hours and then corn syrup for about 27. So in conclusion to the osmosis egg experiment, it's really clear to see how closely the situation mimicked what truly happens in a human cell under similar circumstances. So, I mean, we initially put the egg into the vinegar in order to turn that outer shell into something more comparable to the plasma membrane of a human cell. And it was really interesting to see the osmosis occur and obviously the changes that happen to the eggs throughout. I mean, osmosis is a really unique process because not only is it the transferring of water over a semi-permeable membrane, the water can travel either direction. So just depending on where there's a higher concentration of solution, it'll go either from the cell into the solution or vice versa based on where water is needed more to create that equilibrium. So I mean, the tonicity of the eggs after our experiment, the corn syrup was definitely a hypertonic example. I mean, there was clearly a need for water more so in the corn syrup than the egg, which is why our egg shriveled up. All the water from inside of it booked her over into the corn syrup. And then in the water example, I mean, there was more water in the glass of water as opposed to inside the egg. So our egg just swelled and swelled in an attempt to create that equilibrium between the egg and the glass of water. I mean, if these eggs were true cells, I mean, eventually it would end up causing cell death if it went to an extreme measure. I mean, if the cell shriveled up so much to the point that it had hardly any water in it because it was all going to whatever solution was around it, the cell would shrivel up and die. And I mean, in a hypotonic situation, as was the egg in the water, I mean, eventually the cell would get to the point where it couldn't take on any more water and it would just burst. I mean, homeostasis would greatly be affected by that because if our body was constantly in a state of stress and not having that equilibrium, I mean, all of our cells would be unhappy and lead to death. I mean, that would have to be on an extreme level, of course, because we are composed of trillions of cells, but definitely long-term, it wouldn't be good for our body or homeostasis. Maintaining that equilibrium truly is essential for optimal functioning.